Hey guys, welcome back. We are going to be continuing on in the chapter to section 8.3.1. And you might have noticed from the title of the notes, it says, How can I divide polynomials? So we're actually going to be moving away from complex numbers for the time being, and we're going to focus on this idea of polynomial division. All right, so we're going to take some of these larger polynomials, like these third degree and fourth degree polynomials, and we're going to learn how to divide them by smaller polynomials. And believe it or not, polynomial division is the key to taking some of these higher order polynomials and finding their roots and their factors and things like that. Okay, so we have to learn how to divide polynomials before we can find roots and factors of higher degree polynomials than 2, which is what we've been working with up to this point. So to do this, they're going to be introducing us to a new skill called PolyDoku. All right, they call it a PolyDoku puzzle, but really all it is a generic rectangle. All right, so we've been doing generic rectangles for quite a long time, and what we do is we take these polynomials and we break them up piece by piece, and we create like a column and a row for each one. And then what we do is we go through and we multiply using lattice multiplication, and then we add up the boxes or what's inside of the boxes at the end to get our finished product, right? So let me demonstrate this real quick. We have two polynomials that we are multiplying. I have 2x minus 3, and then I have this cubic polynomial here, and we're multiplying those two, and I want to figure out what that is, right? And like I said, we can use this PolyDoku or this generic rectangle to figure that out. So here we go. I'm going to multiply, so I'm going to multiply the numbers first, right? So 2 times 4 gives me 8, and x times x cubed is x to the 4th. All right, then I keep going, right? 2 times 6 is 12, and x times x squared is x to the 3rd. All right, and this is actually a pretty common mistake that students will make. They will mess up these exponents with these higher order polynomials, so make sure you're careful. Remember, an x by itself has an exponent of 1, right? So this really has a 1 here that we don't write. And then when you multiply those, you just add the exponents together, right? So 1 plus 3 gives me 4, 1 plus 2 gives me 3. Okay, so here we go. So we're going to keep going. 2 times negative 2 is a negative 4, and then x times x is x squared, right? 2 times negative 5 is negative 10, and then there's no x here, but there is an x here, so we'll just have negative 10x. Okay, keep on going here. Let's do the second row. So negative 3 times negative 4 is a negative 12, and then there's no x on this one, x cubed on this one, so it'll just stay as an x cubed. And we've got negative 3 times 6, that's negative 18, and then we have an x squared. And then negative 3 times negative 2 is a positive 6, it's a negative times a negative, and then I need an x on that one, because we have an x there. And then negative 3 times negative 5 is a positive 15. So there's my last box. Right, and some things that I want you to notice here. I'm going to grab my highlighter and highlight this. I want you to notice all of our like terms. You see this one is an x cubed, and the other x cubed is right here diagonal from it. We have our x squareds on their own diagonal, and then we have the x's on their own diagonal. Okay, so we have 4, 3, 2, 1. So the columns kind of go in order, and they will always work out like that. It's a very peculiar pattern that'll help you out in the future. Okay, so let's do that. Let me grab my pen back here. And then down here below, I'm going to go ahead and I'm going to add up my like terms, right? So I have this 8x to the 4th. There's nothing else. There's no other 4th degree term. So I'm just going to bring that down here and I'm going to write it underneath, right? So I have 8x to the 4th. And then I'm going to add up my cubes, right? So it's a negative 12 and a positive 12. So that'll be 0x cubed. And I'm going to add up my x squareds. That'll be minus 22x squared. Then I'm going to add up my x's. So 6 and negative 10 add to give me a negative 4x. And then I've got my 15, which doesn't combine with anything. Right? So this is the multiplication of these two things, right? So 2x minus 3 times this cubic is 8x to the 4th minus 22x squared minus 4x plus 15. Okay, so really not much different than what we've been doing in the past. But the puzzle does become more complicated when they start taking away certain pieces. And that's what we're going to see in this next one, right? So this is why they call it a puzzle, is because we're trying to find all these missing pieces. You'll notice that we're missing pieces out of the top. We're missing pieces down here, but they give us pieces inside of the boxes as well, which they didn't before. And then they also give us one of the things down below. This 12x is much like the negative 4x that we found in the previous problem. So I know that when I add my x's together, I'm going to get 12 of them, right? So it's like a clue. All right, so let's see if we can go through and figure this out. So whatever goes up here, whatever number or whatever expression that I put here has to multiply with this x to get a 2x to the 4th power, okay? So I know right away I'm going to need a 2, right? Because this is really a 1 here, so 2 times 1 gives me that 2. Then I have to think x times something gives me x to the 4th. Well, I know that has to be x to the 3rd. So I was able to kind of work backwards to get that 2x to the 3rd that goes up here. And now that I know this is 2x to the 3rd, I can take this and multiply it with the negative 4 to get negative 8x to the 3rd here. Okay. So then I can do the same thing. Whatever goes here has to multiply with the negative 4 to get 12x squared. So I know I need a negative 3, right? Because negative 3 times negative 4 gives me a positive 12. And I need an x squared, so I have to put my x squared here with the negative 3. Okay? And now that I know this is going to be negative 3x squared, I can multiply that with 1x, so I'll get negative 3x cubed, right? Because negative 3x squared times 1x is negative 3x cubed. All right, so I keep going, right? So I've got 1x times negative 2x, so I can fill this in. This will be negative 2x squared. And then I can do negative 2x times negative 4. That gives me a positive 8x, right? So we're almost there, but then I get here, I don't have the top piece and I don't have anything in this column to help me out with that, but what I do have is this 12x. And I know that when I add up all of my x's inside of this puzzle, I have to get 12 of them. Well, notice that I have 8 already. So the other part of this diagonal, and remember that the like terms occur on diagonals, right? So the 8x is here. My other x term is going to be right here. And I need 4 more x's. So I'm going to go ahead and put 4 x's right here, so that way I know when I add up those x's, I will get 12 of them. So now I'm thinking 1x times something gives me 4x. Well, that's just got to be 4. And then 4 times negative 4 is negative 16. And that completes the puzzle. I now have every single piece. All I have to do is go through and add up my like terms. And I always like to do this highlighter thing because I like to recognize those diagonals, right? The cubes are there. The squareds are there. The regular x's are here. And then these two guys on the corners are always going to be by themselves. There's not going to be anything that they can combine with. All right, so I'm going to go back and get my pen back here. And I'm going to start adding these things together. So I've got 2x to the 4th. And then I've got my cube, so that'll be negative 11x cubed, right? Because negative 8, negative 3. And then I've got a positive 12 and a negative 2, so that'll be a plus 10x squared plus 12x's, right? We had that from the beginning, minus 16. And that completes every part of this Polydoku. So I'm going to go down here and just, it says complete the product. So no problem. We had x minus 4 on the side. And then this other parenthesis is going to be what's here along the top, right? So we've got 2x to the 3rd. And it says plus, but we ended up with a negative 3x squared, so it's not wrong. We can just say plus negative 3x squared, not a big issue, minus 2x plus 4. Okay? And then over here, this is what we get in the bottom, right? The product of these two things is going to be right down here at the bottom of the Polydoku. So we have 2x to the 4th minus 11x to the 3rd plus 10x squared plus 12x minus 16. All right, so I fill in that entire statement. All right, let's do one more. So we got one more here. And again, just some initial observations that I see here. They give me the 2x plus 5, but we don't know what we're multiplying by. That means we don't know anything about this top row, but we know the final result. So we know what the x cubes, the x squareds, and the x's all have to add up to. So we know what these diagonals have to add to. All right. Another cool thing is remember that the first and the last terms, as we discussed in the last problem, those guys are always by themselves. They're not going to combine with anything else. So they actually give us two of the boxes right away. So the 6x to the third is going to go right here automatically, and this plus 10 is going to go down here automatically. So we know the results of those two boxes. And then we can start trying to piece this thing together, right? 2x times something has to give me 6x to the third. So I know I need a 3, right? Because 2 times 3 is 6. And then x times x squared will give me x to the third. Okay, so now I've got 3 times 5, well, that's 15. And then x squared times 5, or I'm sorry, x squared times, well, no x's down here, so we're just going to have x squared, so 15x squared. All right. And then over here, I can kind of come over here. I know 5 times something gives me 10, so I can put a 2 up here. And then I can do 2x times 2, which gives me 4x. So I've got that column filled in. So all I have is this middle column that I need to figure out, which is not a big deal, all right? Because I know that the x squareds, right? Remember our diagonals. Let me grab my pen here. We know that our x squareds have to add to give me negative 7x. Or I'm sorry, positive 7x, okay? So I need to think, what would I add to positive 15 to end up with positive 7? Well, I know I'm going to end up having to take away here. Okay, so I need something that is negative, and it's got to be a negative 8x squared, right? Oops, not there. You need a negative 8x squared here. That way when I add those together, I get that positive 7x. So now I can figure out this top piece, because 2 times something gives me negative 8. Well, that's got to be a negative 4. And x times something gives me x squared, so that's got to be another x, right? Because x times x gives me x squared. So now I know this middle piece up here, and I can multiply that with the 5 to get negative 20x. And again, notice my other diagonal here. My x's, negative 20x and positive 4x, do add to give me that negative 16x. So I know that I have completed my puzzle successfully. Okay. And I'm going to go ahead and finish off this puzzle. I got to fill in this piece down here, and that piece is right up here, right? That's the other polynomial that we're multiplying by. So I can take that 3x squared minus 4x plus 2. And I know that when I multiply those two things, I get this thing here or here at the bottom of the PolyDoku. All right, that's enough for today. That's your introduction to PolyDoku. You guys should probably practice this. Make sure you become really good at solving these PolyDoku puzzles, because they will come in very handy later on when we use this to do division. All right, guys, have a great day.